I take this opportunity to welcome you again in our lesson Computer and or stroke ICT. Here I will be presenting on behalf of PECO Virtual School, and the person who is to present is Mr. Kichui Shedrack Enoch, author of several computer books. Now, when you get this material, endeavor to contact us using these telephone numbers here, so that you can get the series, the order of our material, and you can be assessed. That's when you will be able to understand our work more effectively. Now, last time we started our topic computer hardware. That one was part 1, and now let's embark on part 2. In this part, we shall look at sections of main memory. Remember, we discussed main memory in the previous part of the very computer hardware. Also, we are going to look at other forms of memory, which may not necessarily be main memory, but they are memory too. When we talk of memory, we look at anything which can store. But in this particular discussion, we are looking at the computer kind of memories. Also, we are going to look at computer buffers. We shall understand about computer buffer. Then we shall conclude our topic with a subsection called the machine cycle. Now, before we proceed, there are these important computer books which I would advise you to go and get your personal copy, where you have computer studies O-level, and we have another computer practical which is applicable for both O and A level. They normally call it the bulldozer, because it is really well equipped, and many people have used it and they have benefited a lot. The bulldozer, including some other university students or college students. Then there is C and HTML. These one basically are in O-level syllabus, but even others can learn. Computer is essential. Many people, even those who are not studying as professionals, sometimes they venture and they learn computer programming. So gain interest. With the time, we shall send you material for computer programming. This one is theory for A level. It's called the examiner's word. It is for theory, but basically the material are tailored for A level students or sub ICT. This one is for O level, this one for A level. Now let us proceed. Let us look at the sections of main memory. Sections of main memory. What are the sections of main memory? Memory has two major sections. Main memory, the other primary memory of a computer, it has two major sections. One is random access memory. And this random access memory is normally pronounced as RAM. At times you may be told to ask to write RAM in full. You simply say random access memory. The other is read-only memory. Or in short, ROM. So we have these two sections. Even if anyone tells you what are the two major sections of main memory, you should simply recall random access memory and read-only memory. Now, let us look at random access memory. Random access memory. And that word random, or access, it means that the contents that are within that memory can randomly be accessed, meaning that you can pick any data item from any location without troubling to follow the order, because there are some other memories that when you try to access the content within, you must follow the order. You must go through a series of data items before you reach the item of data that you want to use. But with random, it means you can simply get any piece of information from any location directly. That's the randomness we are talking about. So, what is random access memory? Let's say RAM, or random access memory, the RAM section of memory is a temporary memory that stores operating system, application programs, and data during processing. Now, first of all, the key term here is being temporal. That this random access memory can store information, but information is only stored there temporarily. And what is it for? It stores operating system. Usually operating system like Windows or Linux, but let us assume Windows, which we know. Well, you hear Windows 10, Windows 8, Windows 7, you have heard of such operating system. When they are working, when you put on your machine, your computer, a copy of Windows must be copied from the hard disk to random access memory, because random access memory is a working memory. It is a working memory. When the computer on the machine is working, it uses that section of memory to work. It works from there. That's why it must take a copy of operating system there. But also, not only operating system, but the application programs. An application program may be a Word program. You open Word and you want to type, or you open Microsoft Excel if you have ever used it. Or even when you play computer game, if you have to play the computer game, it must load, and when it is running, it must run occupying the random access memory. So it is the working area. And also data, because when we look at data as the items which are to be processed, assume you have all your marks performed in different subjects and you want the total to be calculated, and the average, and perhaps the position, and so on. So there is a program which has correct instructions to work upon that data, so that if it is summation, can be performed, if it is average, can be performed. But those instructions, which you call application programs, must be in memory plus that very data, and it will be worked from there. That means, that's how we say RAM section of memory is a temporary memory, because that data will be only occupy that memory temporarily. That stores operating system, application programs, and data during processing. That's why they are using this term here, during processing, because if the computer is off, you can't find the operating system there, your data won't be there, and your application programs won't be there. And I will tell you further as we continue our discussion. So RAM contents occupy the memory only temporarily and are swapped with the other contents after they have been processed. That means when a machine is on, the RAM contents that are within the ROM can only occupy the memory only temporarily. But when other data items needs to occupy the same RAM, same location, they have to be swapped with the other contents. That means the contents which were there must be placed elsewhere, but not to continue occupying main memory. Meaning, I can give a scenario of a doctor's room where a patient enter there one by one. So once one patient is worked upon by the doctor, the next patient has to enter, but the other one, the one who was there first, must come out. Should not keep on staying there when the doctor is attending to the next patient. That's what we say when the contents of the RAM's contents, assume the doctor room's patient as the content of RAM, occupy the memory, or we assume the doctor's room, but here we mean memory only temporarily, and are swapped. To swap is like to exchange the position, okay? To exchange the position, are swapped with the other contents after they have been processed. Then when you open your machine, when you open your computer, that box cabinet, when you open it, you will find RAM as a device looking similar to this picture here, this very picture. You can see even labeled RAM. Even if you are to go and buy this RAM, because usually you can purchase RAM if this one has blown out by power or anything, you will see it looking similar like this one. However, in computer hardware, we cannot really have a fixed shape or color or anything of a particular device. They can always, depending on the manufacturer, you may find the RAM also looking something different, not the way you see exactly here. So let us look at the characteristics of random access memory or RAM. The characteristics. When we talk of the characteristics here, we look at its properties. One, the RAM section of memory can both be written and read. That means the machine can write. To write is to store. When you talk of writing, we mean storing information. That means the computer can store that content. It can store something or write it in RAM, but it can also read the content which are in RAM or random access memory. The computer can do that. Then RAM is volatile. What do we mean by volatility or volatile? Its contents disappear when the power has been switched off. That means when the machine is working and there are contents in RAM and the power suddenly goes off, or you switch off the power, anything that was stored in RAM will disappear. That is the volatility we are talking about. That is the volatility we are trying to describe of this kind of RAM. So you hear normally either your teacher at school warning you when you are using the machine that you save, or else your work won't be seen again. Why? The reason is that when the computer is working, anything you are typing, if you didn't save, it means that that information is occupying the RAM section of memory. And once the power goes off, you are not expected to find that information anymore. That's the volatility of RAM we are talking about. So when you save, the meaning of saving is writing or storing. But when you store, you don't store that way. The moment you save and give a file name to, when you give your file a name, it will no longer occupy RAM when you switch off the power. Instead, it will be found in the location within the hard disk or a flash disk, if you save it in the flash disk or a hard disk or any other external storage device. Otherwise, if you do not save, the contents will disappear completely and you will never see it again. So also, RAM is limited in the amount of data it can store. By limited, it means the amount that can be stored in RAM is very small, very small when you compare to the amount that the hard disk can store. So we don't expect that a lot of data can occupy the random access memory. Although in the modern machines, these modern computers, some have very big amount of RAM, okay, but still, however big, cannot surpass that one of hard disk. Hard disk always will be having a large amount of large capacity to store a lot of information. Note, have this note here, that the transfer of data or instructions to the memory is described as writing on the memory. Also, the transfer of data or instructions from memory is described as reading or retrieving the contents of memory. What do I mean here? If you are having any data item and you are trying to transfer that data from any other location to main memory, and actually here we mean random access memory. They just say memory, but usually when we talk of memory we mean RAM. The terms are usually used interchangeably. So when you transfer that data from any other location to main memory or to random access memory, that action is described as writing on the memory. Writing, because you are trying to transfer information to memory or to random access memory, and that action is perfectly being described as writing on the memory. But when you transfer, now if the information occupies the main memory, now it is occupying the main memory, and you want to transfer that information to somewhere else, maybe from the you want to transfer that data or instruction from memory then to any other device, hard disk or monitor screen, it is described as reading or retrieving the contents of memory. So get to understand this concept. Try to replay several times and you get to understand the concept, and read several times. Now let us look at the functions of RAM. Functions of RAM. When we talk of functions, we mean the roles or the uses. What is it used for? Number one, RAM or functions of RAM is to store data and instructions awaiting processing. It means that any information, any kind of data that requires processing, the only place to store that information or that data is random access memory. That data has to be taken and weighted within the random access memory. Just like you can see where patients may be waiting for a medical doctor. Then, to store instructions which are being obeyed or whose parts have been obeyed by the computer. When we talk of obey in computer terms, not the other one we talk at home in English, you say obedience, obeying. But by obeying is to work upon instructions which have been worked upon. Now, because computer receives the instructions to do something, when it does, we say it has obeyed. It has obeyed. So we say to store instructions which are being obeyed. That means which are being worked upon. When the computer is working according to the instruction given, we say to obey. To obey. It is common in computer terms. So don't be confused, but understand it. Whose parts have been obeyed by the computer. So that means that even the instructions that are partly being obeyed also have to occupy the random access memory. Then, to store the intermediate results of computer working before they are communicated to their recipients. When we talk of storing the intermediate results, this is the results that has just come out from the processor working, because it is the processor that performs or work on the instructions to produce the results. So those results which have just been produced still must be stored temporarily within random access memory before they are communicated to their recipients. When you talk of recipients, a recipient can be a user, a computer user through the monitor screen. Okay, so when it get to the monitor screen, that should be the recipient or the destination. Or at times the recipient can be a hard disk, because that information can be saved on a hard disk. So those areas, a recipient can be taken as a destination where it's supposed to be taken. So these intermediate results must occupy RAM before they are taken to their recipients or to their destination. Now, next, let us look at read-only memory. Read-only memory, or ROM. So you may be asked to write ROM in full. That must be one of the simplest questions in computing. In any examination, when you see someone telling you write ROM in full, then that is a free mark. So ROM or read-only memory is a type of storage medium that permanently stores data on personal computers and other devices. Now, you'll ask yourself why this kind of memory is called read-only memory. It means that you can only read, but you cannot write. Remember, random access memory, one of its feature or characteristics was was write and read, but this one you can only read, only reading. You can't do anything but reading. So we say it's a type of storage medium that permanently, while the other one was temporarily, but this one is permanently stores data on personal computers and other devices. When we talk of personal computers, and these ordinary computers we use, like a laptop. A laptop is one of the personal computers, but also it can be a desktop, the other big one that you put on top of the desk. It is a personal computer. And the other devices. The other devices also that use RAM, which later on when you study, you can understand them. So, read-only memory is a type of memory that can only be read but not written. It can only be read but not written by the computer users. So its contents are useful to the machine, and they don't have a direct effect to the user. So what do they mean here? That the contents of ROM are only being useful to the machine. A computer user has nothing to do with whatever is stored in ROM, cannot access anything directly. But the machine itself, when I talk of machine, I mean computer. At times, this word machine is used to mean the computer. Although machines, there are several other type of machines, and the computer is one of them. So at times we can use machine when we mean computer. But this term, when you are writing, when you are dealing with the computing material, don't hesitate to use it or to understand what they mean, so that you may not put any image of another machine, because even a car, it's a machine. But here we are talking about computers. So when we say its contents are useful to the machine, we mean that a computer user cannot determine anything that is stored in ROM, but the machine itself, during its working, there are some usable information that facilitate its working, and that kind of information or data or some kind of programs are stored in ROM. They are stored in ROM, but a computer user cannot determine, because anything that is stored in ROM is done from the manufacturer. When you open your computer case, you'll see that read-only memory in such kind of look. Some of the machines, when you open it, will look something similar like that. When it is out, which is not, when it is not fixed the motherboard, when it is just out, it may look this way when it is independent. Okay, so they can be of different sizes depending on the machine or manufacturer. Now, what are the characteristics of properties of ROM, which you may be asked? Okay, we have looked through them, but this one will help you to also understand some kind of questions which may want you to write characteristics or properties of ROM. One, we can say ROM section of memory can only be read but not written. Can only be read but not written. It means that if you are if you switch on your machine, it can display some information, but that information, by the way, comes from ROM, some kind of information. But you cannot write. You cannot say, let me save, like in a flash disk. You can say, let me save something there. You can't do it in ROM, because it is read only, not writing. Then ROM is non-volatile. Non-volatile, that is, its contents cannot disappear on power switch off. Now, while RAM was volatile, ROM is non-volatile, meaning that its contents cannot disappear even when you switch off the power. That is the ROM. The programs to be executed are already available in ROM during manufacture time. Okay, that the content that is in ROM is available by the time you purchase your computer. You will not be in charge of writing anything there, and that will be ROM. Now, what are the functions of ROM? What are the functions of ROM? One, to store data and instructions that are necessary for the normal functioning of the computer system hardware. To store data and instructions. It means that ROM has some data, it has some instructions too. Okay? But that data is only there. That information, those instructions, they are only there to aid the machine in its normal working. The machine will always need it. So it is there for the to store the necessary data for and instruction for the necessary that are necessary for the normal functioning of the computer system hardware. Then, to store the control program that are necessary for the initial activation of the hardware on power switch on. Usually, all the computer components which are attached, which are within, they need to be initiated before they perform. They don't just start performing, but they need to be initiated. And this initiation or starting of these programs, the instructions are stored in ROM. Also, it performs major input-output tasks. There are some instructions there that one of the tasks is for input and output tasks. When these tasks are performed, ROM, all the instructions which are there, are basically doing that. Note, this type of instruction or this type of memory is often referred to as the firmware. This type of memory is often referred to as the firmware. Why? Because its content is written from the manufacturer and can hardly be altered by the user. When I say can hardly be altered, I mean they cannot be changed. They can hardly be changed. Alteration means changing. So, because they are hardwired or they can't be really changed, they are described as the firmware. All these instructions that are written there cannot be changed. So ROM is always referred to as the firmware. Now, let us look at the ROM extension. ROM extension. Now we understand that ROM or read-only memory is only for reading, but you cannot write. You cannot do anything. But there are some extensions that have some extended description. One of these extensions is PROM. PROM. Now, what is PROM? PROM alone stands for Programmable Read-Only Memory. Programmable Read-Only Memory. Now, to program, when we talk of program or programmable, it means that it is that ability to be written. This programmable, it means that it can be written. It is a kind of ROM that can be written. That's why I say programmable, read-only memory. So these are kind of, that's how we talk of some ROM extension. It is a version, it is some higher version that is described as the PROM, or programmable read-only memory. So the ICs, or integrated circuits, the ICs of ROM are bought when they contain no data or instructions. They are bought when they contain no data or instruction. Remember, ROM is purchased with the data written from the manufacturer. But PROM, which is programmable, this one is bought when they contain no data or instructions. They don't have any data or instructions. So they are being programmed by their users as appropriate. That means when you buy PROM, it's like buying an exercise book so that you can write. When you buy ROM is like buying a Bible or a textbook, whereby you are just reading. When you write, you are just forging, but you are not supposed to write. But PROM, you buy it empty. When it is empty, just like there you buy an exercise book, a counter book, which is blank, and you will simply go there to write. So this similarity can be compared to can be matched with the PROM, whereby we say the ICs of PROM, or programmable read-only memory, are bought when they contain no data or instructions, and they are being programmed by their users. When you say that they are being programmed, we mean they are being written. They can now be written by their users as appropriate. When we say as appropriate, we mean the way the user like it to be, because with the ROM, a user had no choice. The way the instructions are set, he will have to abide by that. But as of PROM, a user can decide to set the instructions in the way that is appropriate to him, after which their contents remain strictly read-only. So when you purchase PROM and you program it or write on it, you cannot again erase and write. It now remains read-only after you writing. It's like after you using a pen, using a pen to write on an exercise book. Usually you can't erase to write something else. No, you can't even alter. That's why if your exercise book is full, if you don't need to keep it, you may just have to throw it away, because it cannot work for you to write again. And that is PROM. But ROM is like your Bible, where you buy when it has content and you can't write. That is ROM. But PROM is like your exercise book, where you buy when it is empty and you can write what you want. You don't depend on like the textbook, which you read what is there. But the exercise book, you write what you want. So even PROM, you write what you want. But after writing, it remains strictly read-only. Strictly read-only. It will now remain no more ROM. It will only allow you to purchase it when it is empty, like ROM, and now able to write. So EPROM, or electronic or erasable programmable read-only memory. Erasable programmable read-only memory. Now, PROM, once you write, you purchase when it is empty. I'm coming back to PROM. You purchase when it is empty, you write, but you can't erase. It remains only read only. Okay. Now, EPROM stands for erasable programmable read-only memory. What does it mean? It means that the ICs of EPROM are bought when they are not programmed. Just like EPROM, they are bought when they are empty. When we say not programmed, it means not written. So they are bought when they are empty, blank. So after which they are programmed now as appropriately. You can program per requirements the way you want, as the way the user want. Okay. After which they can be subsequently being erased using ultraviolet light or electrical pulse and be reprogrammed. Okay. Now look here. I have to, when I make this explanation, let us compare. This one you buy where it is empty. You write, but you can't erase. But EPROM, you buy when it is empty. You write, but you can erase. That's why it is called erasable. They have added the E here to show you that this is erasable. It is an erasable programmable read-only memory. Why? Because you purchase when it is empty, then you can program it or you can write it. When you look at this, you can program. It means you can store, you can write. Such terms you need to get used to them in the computer, because at times when you hear someone says can program or can write, you get confused. Write how? No. When we talk of write, it means you can store. When we talk of programmed, it means that you can also store, but not computer programming. That one is something else we shall look at with the time. But here, at this particular explanation, we mean whereby you have a memory which can allow writing the content. So they are programmed appropriately as per user requirement of the user, after which they can be subsequently being erased using ultraviolet light or electrical pulses and be reprogrammed after being erased. But remember, erasing content from EPROM, you must use ultraviolet light. You don't just erase normal like the way you erase the work on flash disk or hard disk. No, you use special rays called the ultraviolet rays light or electrical pulses, after which you can reprogram. You can write again. So the other one is the double EPROM. EEPROM. So this one is another version compared to EPROM. This one is the EEPROM. What does it mean? It stands for electrically erasable read-only memory. Electrically erasable read-only memory. This one is a form of semiconductor memory. In which the entire contents can be erased by subjecting the device to suitable electrical signals. After erasing, the device can be reprogrammed. This procedure may be repeated hundreds of times without damaging the device. Now, you may ask, what could be the difference between EEPROM and PROM? The major difference here, much as both can be erased and rewritten. Both EPROM and EEPROM. Both can be erased and rewritten. The only difference is that you do not need ultraviolet rays to erase the content in EEPROM. You don't need. This one will just be a click of a button somewhere to erase the content. That's why they say you can just subject it to the device using suitable electrical signals. When we talk of suitable electrical signals, these signals can be triggered using key buttons from the keyboard, from the mouse, and we are able to erase the content in EEPROM. But when it comes to EPROM, you need special rays for erasing. Now also they say that this procedure of erasing may be repeated hundreds of times without damaging the device. EPROM, much as it can be erased, but if you overdo it with the ultraviolet rays, the device can get damaged and it will remain unusable. So it will not be something to do over and over and over again. But with the EEPROM, you can erase the content several times, but you will not damage the storage. Now, let us look at other forms of memory. Other forms of memory, of computer memory. Since we are looking at random access memory and then read-only memory, which are under the main memory, but there are other forms of memory, and usually they are internal. They are internal memories, but other forms. How are they? Say the performance of microcomputers can be further enhanced by adding other forms of memory as follows. We have cache memory. Cache memory. This memory is popular in most high-speed machines or machines with a very high-speed CPU. But let us look at the description that cache memory, also called the CPU memory, is random access memory that a computer microprocessor can access more quickly than it can access regular RAM. So we understand here that the cache memory is also random access memory because its content can randomly be accessed. But why elevate it into cache? Because it is a part of memory that is installed within the system because of its speed, especially when the computer's CPU memory is too fast. The machines which have the CPU which operate at a very high speed may not be well interact with the regular RAM. So what the technique they use is to install very fast random access memory called the cache memory. Okay, now cache memory is a special high speed memory area that the CPU can access quickly. The CPU is able to access that area of memory very quickly. It means that in the regular RAM, the ordinary RAM content, they have to first be transferred to the cache memory before the CPU can make interaction with it. So cache memory is used with the computer with the very high speed CPU. Very high. It means that if your machine or the computer is not meant to perform very fast, then you may not need the cache memory. But with the computer which are known to be having a very high speed CPU, then they may have to install an additional memory called the cache memory. so that the machine can perform at its best. The most frequently used instructions are kept in cache so that the CPU can look there first. When you say the most frequently used instruction, there could be some data that always the CPU needs, so it has to put there first. Or it can be like a doctor always working with that instrument for measuring maybe pressure of a patient or what. You know that instrument, they hang it on the neck because they know they will use that one frequently. They will not work with the CRT or CTI scanner. No, they will not move with the CTI scanner. That one they don't use it frequently. But there are some instruments that they use it frequently, so much frequently, so they have to keep on holding nearby. So even the CPU here, with the instructions that it uses frequently, must be stored in cache memory. Now, this allows the CPU to run faster because it does not have to take time to swap instructions in and out the main memory. It will work faster because it will not always go to main memory or regular RAM to get those instructions which it needs it frequently. Now, let us look at the diagram showing how cache memory works. This diagram will aid us. Here is how we normally, all the time, data is loaded to main memory. Always. But main memory has low speed. It communicates at the low speed. But CPU usually communicates at a very high speed, as you can see. Very high speed. Now, because of that, information that the CPU needs quickly has to be transferred here to be written in cache memory, so that the CPU can quickly access that data from cache memory to the CPU for working, because CPU is the processor. When we talk of CPU is the processor which works upon the instruction. It is one that obeys, execute the instructions. But it will also communicate back the results through cache at a very high speed, but it will try to send it at the low speed, the speed of main memory. And the cache can always regulate that. Now, still another diagram here for cache memory. It tells us that in between CPU and the cache memory, here a word transfer. That means a full word can be transferred. But here, main memory and the cache, it is block transfer. Okay, block, like when we talk of block transfer, can be a character with several bits. Block transfer, a character, a single character. But here a full word like memory can be transferred because it is very fast. So this memory is the fastest memory in a computer, very fast. If you have to open your machine, you may find your cache memory in such kind of appearance, but you may also mistake it to be ordinary RAM, but this one has a lot of speed. Now, the other memory, they call it video memory. What is video memory? Video memory or video RAM is a chip. Okay, video memory or video RAM chips are used to store display images for the monitor. That means using your monitor, since there are several images, they need a special memory that is faster and able to process those images very well. So that is the work of video memory. The amount of video memory determines how fast images appear and how many colors are available. So a computer with many colors and which images appears very fast without showing any difficulties, it means that the amount of memory, it has good video memory, and that's the work of video memory. Video memories are particularly desirable when you are running programs that display a lot of graphics, like a computer game. You can't play a computer game without a good graphic cards. Those are video memories. They will talk of graphic cards. So you need a good video memory in order to deal with those graphics, or heavy videos. The other, we have flash memory. Flash memory. A flash memory is mainly used in notebook and sub-notebook computers, or cellular phone, digital camera, and personal digital assistants. This kind of devices will always have the flash memory. What are flash memory? These flash memories are non-volatile. It means that when you store information there, will not disappear, will be stored there permanently. Now, you may have seen some of these kind of memories. Some of you are aware of these memory cards. You have memory cards, flash disk. They are flash memories. Okay, although you normally look at the flash disk as the only flash memory, but even these other, even your SIM card, it is a flash memory. You can store some data, phone numbers, sent messages, received messages. Such cards, they are video memories. Even some other machines, they use these flash memories. Not video memory, but a flash memory. Now, in some other kind of devices, a video memory can be fitted somewhere so that it can be read or written. BIOS ROM. We have discussed about read-only memory. That one of the work of read-only memory, they say this is a type of memory that contains the basic input-output system, which is the sequence of instructions the computer follows to load the operating system and other files when the computer is turned on. Now, we are simply talking about the very ROM here. It is not any different from the ROM. That this ROM, or BIOS ROM, we mean ROM, another task of ROM is to store this kind of instructions called the basic input-output system, or BIOS. You have heard about the BIOS. That word BIOS is very common in computing. Now, what are BIOS? Maybe you may be asked, what is BIOS? What is BIOS? In a question of this type, what is BIOS, or basic input-output system? These are sequence of instructions the computer follows to load the operating system and the other files when the computer is turned on. Because the moment you switch on your computer, the first thing the computer does is to load the operating system onto main memory, or random access memory, the RAM. But the instructions which are supposed to direct or to aid the loading of those of the operating system into random access memory are basically BIOS. Now, Let us look at the complementary metal oxide semiconductor. Complementary metal oxide semiconductor. Now, all the other term is CMOS. You may have heard of CMOS without knowing it in full, but in full it means complementary metal oxide semiconductor. Be keen of these abbreviations. Sometimes in examination they tell you to write them in full. BIOS in full, CMOS in full, ROM in full, RAM in full. So you should know. So this you should know that it's complementary metal oxide semiconductor. Now this one is used to store. It is a memory, and its work is to store configuration information about the computer, which includes amount of memory, disk drive, keyboard, monitor, current date, and time. Now, configuration information. When you hear of configuration information, a computer is there, but there are so many other devices attached to it. The keyboard is attached, the printer can be attached, the hard disk, and many other devices. Now, all the devices which are stored there, which are attached, we assume that is the configuration. But that information, the system needed to have a record, of all the devices that are attached and how they work, so that it can manage them. With that information is recorded in this memory location called CMOS, or complementary metal oxide semiconductor. By storing this configuration information, when you talk of configuration information, is that type of record showing which kind of devices that are attached. But the other thing also is current date and time. So CMOS chips use battery to retain information even when power is turned off. So when you turn off your machine, everything has gone off, but inside there will be a battery like that one of a clock or of a watch, hand watch, whereby will aid the continuous storage of that kind of information to read the time and date. Will not, if you see, you can switch off your machine, but when you switch it on, it still shows date of time properly. It is because there is a battery inside there that keeps that information of date and time. Now, unlike ROM, information stored in CMOS can be changed. You can change the configuration, not like the way ROM is. Look, that CMOS, if you open your machine, can have something to this image. It will look similar to this image here, okay? And somewhere a battery can be, the CMOS battery is round like that. Usually it is round. However, these one are useful to you, these images, for those people who admire to go and become technicians. Otherwise, we can't be told to paint or to draw such kind of pictures in any examination, but simply no, because with the time you may open your machine, you should be able to understand the devices which are there. Now, let's move to another item called the computer buffer. Computer buffer. Now, what are buffers? The computer buffer is a special purpose temporary memory. Special purpose temporary memory means that they also store data temporarily. Memory location used during input output. When we say input stroke output, we mean used during either during input or used during output or used during processing to hold data and or instructions. It means to hold both data and instruction, or to hold data alone or instruction between communicating devices. It means that this buffer or this kind of memory usually works in between two communicating devices, and I will explain to you how. So the role of buffer counterbalance the speed differences between two communicating devices elements by accepting data or instructions that are at the speed of the sending element and remit them at the speed of the receiving elements. Okay? Now, buffers are always working, they operate in between the two communicating devices, but which differ in speed. When we say the speed differences, it means that they differ in speed. Like when you look at a plane and a normal car, they don't have the same speed. Okay, they don't have the same speed. And even these devices, you will find that some devices have much higher speed than others. So buffers counterbalance the speed differences between two communicating elements by accepting data or instructions at the speed of the sending element and remit them at the speed of the receiving element, as we are going to see. So the form of buffer are, we have input buffer and output buffer. Input buffer and output buffer. Now look, what are the input buffers? Input buffer is used between the input device, which is the sending device, and the CPU, the receiving device. That when you have the input device like a keyboard and you are typing, you want to communicate anything to the CPU, then there in between you will have the input buffer. And why is done so? Look at this diagram. Here you have the input device, say a keyboard or a mouse, and you are trying to type something, and you want it to go to the CPU, but the CPU and the input device, they differ in speed significantly. The CPU's speed is very high, but the input device speed is very low. Now because of that, we say the input buffer has to receive that information from the input device at the low speed, because input device is slow, so it will adjust and receive it at the low speed, but after which it will remit that data at a high speed of the very CPU, because the CPU cannot communicate directly with the input device. It requires that buffer to counterbalance the speed imbalance or the speed differences between the two communicating devices. So the two communicating devices here should be input device and the CPU. They are trying to communicate, but they differ in speed. In between, they have to put in the input buffer to aid that communication. So the role of input buffer, therefore, is to accept data or instructions at the speed of the input device. So the role of input buffer here is to accept data at the speed of input devices. As you can see here, low speed, which is comparatively low, and remits. To remit is to send. To remit is to send. To remit is to send, and remits them at the high speed of the CPU to go as computer inputs. Because anything from the keyboard or from the input devices is meant to be input. You can't have output to the keyboard, no. So anything that is from the keyboard or from any input device, then all the contents are going as the inputs. Now let us look at the output buffer. The output buffer is used between the CPU and the output unit. Now what that mean? Look, if you look at this sketch of a diagram, you have the CPU, you have the output devices, then in the middle you have the output buffer. But why is it that the buffer is here? The buffer is positioned here because the CPU is operating at a very high speed compared to the output devices. So the work of the output buffer therefore is to receive data or instruction from the CPU at the high speed of the CPU, but thereafter it can remit at the low speed of output devices, like the way you see here. That's why it is here. So the two do not operate. I can compare a buffer like a person waiting for a taxi. A taxi has to stop because you do not have the same speed as its ability to move. Otherwise, it didn't need to stop for you to board. So it stops because it needs to match your speed, then you board, then it can again start its speed. So when it comes to the role of input buffer here, say the role of the not input but output, the role of the output buffer is to accept data and instructions, to accept data and instruction at the speed of the CPU and remits them at the low speed of the output device to go as computer outputs, When you see outputs and there is S here, outputs, it means that is the information. Output device, that is a device. But when you say outputs, it means information out. When you say inputs, where there is S, it means that is data input. That is data to be put in. Now, the process of using the buffer to control the speed of communication between the CPU and the peripheral devices is known as buffering. So you may be asked, what is buffering? You should know that buffering is the process of using the buffer to control the speed of communication between the CPU and the peripheral devices. A peripheral can be either input device or output device. All of them are peripheral devices. When they communicate with the CPU, the buffering process has to take place. Now, let us look at machine cycle or the processor cycle. Now, when you talk of machine cycle, the machine cycle is a series of operations performed to execute a single program instruction. Series of operations. It means that there are several operations, but they are performed to execute or to work on a single program instruction. That means just a single instruction requires a series of operations, as we are going to say. So the machine or CPU cycle consists of four steps. Those operations are four. One is fetch. The second one in their order is decode or interpret. That means decode means to interpret. Fetch is to get something hidden somewhere. Then execute. You fetch, you decode, then execute, then you store. So these four operations describe machine cycle. The four repeating operation. When you say cycle, you mean these are processes that do repeat. So once the machine encounters just a single instruction, the first thing it has to fetch that instruction or to obtain the instruction. Then after obtaining the instruction, it decodes or interprets that instruction. Why interpreting it? It interprets because it will use those instructions, make them understandable by other devices within the computer system. So it has to decode, because usually these instructions at times they are in human sensible form, like the way you type on your keyboard, you type some instructions, you type some data. So the machine must make it must decode or interpret those signals which are coming from outside the environment or in human sensible form, so that they can be understandable by other components that are to process that data. Then after that is to execute. To execute, we say, is to work upon. If you are told to do something and you do it, that means you are executing or you are obeying. Then after, you will get the result. That means when you have the result, the next thing is to store. After you have got the result of what you are supposed to do, the next thing is to store. Now come to diagram showing machine cycle. Diagram showing machine cycle. Here the machine cycle shows that in the first point it has to fetch. The very first point, the first step is to fetch. To fetch what? To fetch instruction. Okay. Then here is that very instruction that is supposed to be worked upon. So the first operation is to fetch, then followed by decoding, to decode that instruction, then followed by executing, to execute that instruction, then followed by storing the information. The word store is just here. So it means you go by fetch, decode, execute, store. Fetch, decode, execute, store. So with that, we have this part here with the red color, which has fetch and decode. This step from fetch and decode is known as I time. I time. So if someone asks you what is I time, it is these two steps, fetch, decode, which we are going to see them later. Then when we come to execute, store, execute, store, these two steps are known as execution time or E time. I time means instruction time and E time means execution time. So with the I time, that is the time the machine will take it to fetch the instruction and to decode that instruction. That time lapse that will be taken to fetch and decode the instruction until that activity is done, it is called I time or instruction time. But also the time the machine takes to execute that instruction and store, that time is known as E time. E time. So before an instruction can be executed, program instructions and data must be placed into memory from any input device or secondary storage device. Now from there, once the necessary data and instructions are in memory, the central processing unit or machine, remember the machine is that central processing unit, performs the following 4 steps for each instruction. The machine performs the following 4 steps for each instruction, of which number 1, the control unit fetches. The control unit fetches. That means it is the control unit that is in charge of fetching the item of data or getting, fetches or gets the instruction from memory, because that fetching is done from memory. It is the instructions are obtained from memory because that's where they are temporarily stored during processing. So the machine will be fetching them. So you go back and look at the other diagram and watch again that part, and you will understand what we mean in our part 1 of hardware. Watch, especially listen to the explanation of that diagram. So the control unit fetches or gets the instruction from memory. Then the control unit, the second step, decodes the instruction or decides what it means and directs the necessary data to be moved from memory to the arithmetic and logical unit. These first 2 steps together are called instruction time or I time. Instruction time or I time. So The I time is that process of fetching and decoding. Then the arithmetic and logical unit, after the machine has done the part of I time, after the machine has done has completed, which we call I time, that portion. Now the next is arithmetic and logical unit, which executes the arithmetic or logical instructions. That is, the ALU is given control and performs the actual operations on the data. Then the arithmetic and logical unit stores the result of this operation in memory or in a register. We shall talk about register later. So step 3 and 4 together are called execution time or E time. The step 3 and 4 are called E time or execution time. And this step 3 and 4 are performed by arithmetic and logical unit, whereas step 1 and 2 is control unit, because control unit is one that can fetch and decode, and the arithmetic and logical unit can execute, and thereafter the result that it gets, it stores it somewhere in register or memory. With that, I thank you very much for listening to me. It is too much raining there, but don't worry. There it just shows the author, and the books that he writes, they are always in Angelina, or you can find them in Aristo. Ask direct to points computer books, you will get your copy there. And if you want to run computer programming, which you must, because in the tutorial that we send, we shall send you also the tutorial for computer programming, especially for O-level students. For them, they need it, but for A-level, you can do it yourself programming after completing your studies. Thank you.